All right, welcome to The Explainer. Today, we're jumping right into the most fundamental part of any Apache Spark job, getting your data in. You can't analyze what you can't load, right? This is the foundation for everything else you're going to do. So we all know Spark is this incredibly powerful tool for analytics. But before you can work any of that magic, you got to ask a really basic question. How do I even get my data into Spark in the first place? It all boils down to its core data structure. Think of it as the starting line for absolutely any project you'll run. So what is this foundational piece we're talking about? It's something called an RDD. And trust me, this isn't just some jargon. It is the absolute bedrock of any Spark application. If you can get your head around this, you're on your way to unlocking what Spark can really do. Yeah, resilient distributed data set. It sounds like a mouthful, doesn't it? But the concept is actually pretty straightforward. Just think of an RDD as the main box you put your data in when you're working with Spark. And hey, if you're coming from a database world, it's a lot like a table. The big difference, though, is that this table can't be changed. It's immutable, and Spark automatically chops it up and spreads it across a bunch of computers so they can all work on it at the same time. Pretty cool, right? Okay, that's the perfect next question. You know what an RDD is, but how do you actually make one? Well, the how is surprisingly simple. Spark basically gives you two main paths to get started, and picking the right one, well, it all depends on what you're trying to do. So here are your two big options. First, you can take a small bit of data you already have sitting in your program, like a list of names or numbers, and tell Spark to parallelize it. Or, and this is what you'll be doing most of the time with big data, you can just point Spark to a huge data set that's already living somewhere else, like in a distributed file system. Exactly. Think about it. When you're just trying something out, maybe prototyping a new idea or just writing a quick test, the last thing you want to do is deal with a massive, complicated data set. And for those moments, Spark has this really elegant, simple way to create an RDD using data you can literally just type right into your code. And that method is called parallelize. The name kind of gives it away, right? It takes a collection of data that's already sitting there in your program's memory on what's called the driver node, and it parallelizes it. It spreads it out across your whole cluster so you can process it in parallel. It's absolutely perfect for those quick and dirty experiments. Okay, so that's great for testing, but what about the real world? When you're not just playing around anymore, when you move to a real production application that's crunching huge amounts of data, you're going to need something way more scalable. Let's be real, you're not going to have your entire terabyte-sized data sets just sitting in a list on one computer. And for that, we have the textfile method. This is the real deal. It's the workhorse, the standard way you create an RDD in a production environment. All you have to do is point it at a file sitting in some external storage, think HDFS or Amazon S3, and boom, Spark handles all the heavy lifting of reading it in parallel and turning it into an RDD where each item in that RDD is just one line from your file. So now we've got our two methods. And how do you know which one to use? Well, it's all about context. It really just boils down to one simple question. Are you just testing things out, or are you building something for production? Let's put them side by side and see how they compare. And this table here just makes it crystal clear, doesn't it? Take a look at parallelize up top. Its whole purpose is prototyping and testing, and it assumes your data is already loaded into memory on a single machine. And that right there is its biggest weakness. Your entire dataset has to fit in the memory of that one driver node. Now, compare that to textfile. It's built for production. It expects the data to be out there in some distributed storage. That's how you get scalability. This quote really just hammers the point home. Look, parallelize is a fantastic tool for learning and for testing, but it has that one major limitation. If your data is too big to fit into the memory of one computer, you just can't use it. It's a total non-starter for any real-world app. And this is exactly why picking the right creation method from the get-go is so important for your application's performance and whether it can scale up. So let's just quickly recap this two-step process, because it's really simple but super powerful. Step 1, you start out prototyping and testing your ideas with parallelize, using a nice small in-memory collection of data. Step 2, once you've got your logic all figured out and working, you just swap it out for textfile and run the exact same code on your massive, real-world datasets that are living in external storage. It's a beautiful workflow. And that's pretty much it. You now have the fundamental tools to create an RDD from pretty much any data source you can think of. It doesn't matter if it's a tiny little list for a quick test or a massive petabyte-scale log file for a huge production job. You've officially taken the first and honestly the most important step to unlocking the real power of Apache Spark. Hey, if you found this explainer helpful, do us a favor and hit that like button. And if you know someone else who's getting started with Spark, go ahead and share it with them. And of course, make sure you subscribe so you don't miss out on more explainers just like this one. Thanks for tuning in.